Assalamualaikum warahmatullahi wabarakatuh. Ladies and gentlemen, I introduce the students participating in the Phytotechnology class, the International Undergraduate Program, Environmental Engineering Department, Institut Teknologi 10 November, Surabaya, Indonesia. Students present papers, and with their permission, their presentations may be shared online with anyone via my YouTube channel. I consider this method as my responsibility in educating students who in the future will be able to independently develop their knowledge and skills in expressing ideas. Come on, let's look at the following thoughts. Thank you. Wassalamualaikum warahmatullahi wabarakatuh.
Good morning, everyone. Today I would like to present my topic, which is the use of technology to determine the plant species for phytoremediation. First off, my name is Adri Sulthan Ervandi with LRP 50142113, class IB. So first off, what is phytotechnology? It is the use of vegetation to contain, remove, or degrade inorganic and organic pollutants that is found in fossils, sediments, surface waters, and groundwaters. And the topic that I'm going to discuss is about phytoremediation. So first off, what is phytoremediation? It is a method that effectively removes various contaminants from soil and water, including heavy metals, organic compounds, radionuclides, antibiotics, and oil spills. Next, plants. So the characteristics of plants are they can absorb heavy metals, lower their toxicity, and break down organic compounds via photodegradation and laser degradation. They can immobilize radionuclides in wastewater, aid in environmental detoxification, and stabilize hydrocarbons in oil spills. Phytoremediation is a sustainable and cost-effective method for environmental restoration. So, apart from phytoremediation, we can also use these plants for green spaces. And green spaces are essential in urban settings, which gives a significant environmental, social, and economic advantage. However, using the appropriate plant species for green space development is critical to ensure optimal ecosystem services and sustainability. So, what are the aids in phytoremediation? So basically, there are a variety of assistants that can be utilized to improve phytoremediation processes, which includes natural modifications, chemical modifications, genetic engineering, and microbial stimulation. These aids promote phytoremediation efficiency by increasing plant contaminant uptake and accumulation, stimulating plant growth in contaminated environments, and facilitating pollutant breakdown or immobilization in soil or water. Now, the examples for natural modifications are SPR, composted sewage sludge, paper waste, and biochar. Whereas chemical modifications such as EDTA, EGTA, and SDS. For microbial enhancement, it is EGPR, EGPE, and AMF. Whereas genetic engineering is gene transfer, manipulation, and closing. So plant classification is important because it affects the efficiency and effectiveness of pollutant removal. Plants with higher tolerance to pollutants, absorption capacity, biomass production, growth characteristics, and compatibility with the site circumstances that are required. Plants with high absorption capacity can effectively absorb contaminants lowering their concentration and allowing for quick disposal. Plants with high biomass production rates can effectively remove pollutants. By carefully selecting appropriate plant species, practitioners can optimize the remediation process and achieve excellent results in repairing damaged soil and water resources. So these are the plants based on carbon dioxide absorption has two classifications, which are local wisdom-based plant species, which is scientifically proven to exhibit superiority in the rate of carbon dioxide absorption. And specific absorption rate fluctuations were observed in certain local plant species throughout the day, indicating variations in their carbon dioxide absorption capabilities, and the importance of incorporating local plant species into existing green spaces to enhance the specific absorption rate of carbon dioxide. And the next one is urban greening plants, which plays a role in carbon dioxide absorption within the green space ecosystem. This study highlights the significance of biodiversity in green space ecosystem, emphasizing the need for a diverse range of plant species to complement each other's advantage and disadvantage in carbon dioxide absorption. Next, we have the phytoremediation processes. So here I used an image from Kafka. And so there are lots of processes. First one is phytovolatilization, which is the loss to atmosphere through evapotranspiration from dermal layers of stems and leaves, which you can see from the leaves of this tree. And then we have phytoextraction, which is the method of uptake and formation of ligands and salation. We also have phytodegradation, which is metabolism of toxicants of phytoenzymes. We have also phytodegradation, which is the metabolism of toxicants by the root enzymes. We also have phytodesalination, which is the uptake of mineral ions. Rhizofiltration, which is the uptake from groundwater, followed by metabolization or precipitation inside the roots. And also phytostabilization, which is the formation of residue that bonds molecules and complexes with biomolecules. So here are the examples of plants that are used in phytovolatilization. First, we have rabbitfoot grass, which has a scientific name of Polypogomont paliensis, which uses the contaminants such as arsenic. We have common rush, which uses ammonia, and broccoli, which uses selenium in the phytovolatilization process in phytoremediation. Next, we have phytoextraction, and the plants. These are the examples of the plants, which are lettuce, corn, and tobacco. Lettuce utilizes nickel, copper, and iron, whereas corn utilizes lead and titanium, and tobacco utilizes cadmium. Next is phytodegradation, which uses duckweed, coral, and elodea. And duckweed utilizes ofloxacin, which when I searched it up, it's like antibiotic material. We also have coral, which utilizes textiles and soda dyes, and elodea, which uses DDT. We also have desalination, which have plants such as water spinach, alkali grass, and cattail. For water spinach, it utilizes sodium. For alkali grass, it uses sodium ion and chloride ion. For cattail, it uses sodium and chloride. For phytostabilization, it uses the examples are sunflower, cowpea, and black nightshade. For sunflowers, it utilizes copper, zinc, lead, mercury, arsenic, cadmium, and nickel. For cowpea, it utilizes lead and zinc, whereas black nightshade utilizes copper, zinc, and cadmium. For rhizodegradation, it uses mangrove, rapeseed, and sesbania. For mangrove, it utilizes phenanthrene and pyrene. And rapeseed, it uses 2.4 dichlorophenol, and sesbania utilizes lead. For rhizofiltration, the examples are water starwort, pond water starboard and water high active. For water starboard, it uses arsenic, whereas pond water starboard uses uranium, and water high active uses iron, chromium, copper, cadmium, zinc, nickel, and arsenic. And these are natural and synthetic substances that can help with the phytoremediation processes. So first off, we have soil amendments, which uses biochar and ethylene diamine tetratic acid. For microbial agents, it uses endophytic bacteria and marsupial mycorrhizae. And transgenic plants, which is genetically engineered plants, and plant growth promoting bacteria, which is Staphylococcus, Maltophilia, and Agrobacterium. So in conclusion, phytoremediation is regarded as a long-term option for pollution remediation, since it has a low cost and ecologically acceptable method of cleaning up contaminant soil and water with plants. This technology is renewable, does not require considerable infrastructure, and can be implemented on-site, minimizing the need to transport polluted materials. Additionally, phytoremediation can be combined with other remediation strategies, making it a more versatile and effective tool for dealing with a wide range of toxins. Thank you very much for listening to my presentation. Sorry if there are any mistakes. Yeah, thank you. Assalamualaikum warahmatullahi wabarakatuh. phytoremediation is regarded as a long-term option for pollution remediation, since it has a low-cost and ecologically acceptable method of cleaning up contaminated soil and water with plants. This technology is renewable, does not require considerable infrastructure, and can be implemented on-site, minimizing the need to transport polluted materials. Additionally, phytoremediation can be combined with other remediation strategies, making it a more versatile and effective tool for dealing with a wide range of toxins. Thank you very much for listening to my presentation. Sorry if there are any mistakes.